I am Aditi Shima from Penn University, and today I'll be talking about recursive algorithm. What is it? An algorithm is said to be recursive if the same algorithm is invoked in the body. It basically calls itself with smaller input values and returns with the current input by carrying out basic operations on the returned value for smaller input. Fabiconi number series, generation of factorial are some examples of recursive algorithm. What are its types? Well, there are two types of recursive algorithms. Firstly, the direct recursive, and secondly, the indirect recursive. An algorithm is said to be direct if it calls itself. Basically, the function makes a recursive call inside its own functional body. And an algorithm is said to be indirect if it calls another function, which then in turn calls that algorithm. And for indirect recursion, both the functions need to be declared before they are defined. For example, if there is a function A, then it will call a function B, and that function B will call the function A again. This is called indirect recursive calling. Now, every recursive algorithm has two elements, namely, firstly, the base case, and second, the general case. Base case is basically the statement that solves the problem. Every recursive function must have a base case, and each call reduces the size of problem. Rest of the function is called general case. How to design a recursive algorithm? Firstly, determine the base case. Secondly, determine the general case. And third, join the general case and base together to form an algorithm. Now let's have a few examples to practice. Firstly, let's solve a problem using recursive manner. For example, we would be taking the problem named Tower of Hanoi. So the problem is, as the disks were very heavy, they can be moved only one at a time. In addition, at no time can be a disk on the top of a smaller disk. So let's now solve this it in a recursive manner. Firstly, we will need to figure out a base case and a general case as follows. Our base case would turn out to be move one disk from the source to destination tower, and a general case will be move n minus 1 from source to intermediate needle. Now, the solution will be as follows. Firstly, move n minus 1 disk from source tower labeled as A, for example, to intermediate tower labeled C, for example. Secondly, move one disk from source tower labeled A to destination tower labeled B, for example. And thirdly, move n minus 1 disk from intermediate tower labeled C to destination tower labeled B. And hence our problem is solved. Here is the algorithm to solve the Tower of Hanoi problem recursively, where n is the number of disks and A, B, and C are the towers. You can take a look at the code. Now, let's find out the factorial for a number in a recursive manner. So firstly, let's figure out our base and general cases as follows. Our base case would be factorial of 0 would be equal to 1 and factorial n would be equal to n multiplied by factorial n minus 1. Therefore, Here is our algorithm to find factorial of a number n as follows. You can take a look at it. Now moving on to the last example, let's generate the nth term in Fabiconi series via recursive algorithm. The Fabiconi for a few numbers is as follows: 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. So let's figure out a base and general cases as follows. Firstly, our base case would turn out to be Fibonacci of 0 would be equal to 0, Fibonacci of 1 would be equal to 1, in general case would be Fibonacci 9, Fibonacci, I correct myself, Fibonacci n would be equal to Fibonacci of n minus 1 multiplied, nahi, correct myself, um, added to Fibonacci of n minus 1. So I'll say this again. General case would be Fibonacci of n equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. And therefore, we'll write the algorithm to generate the nth value in Fibonacci series. You can take a look at it. So here we come to an end of a basic introduction to recursive algorithm. Thank you so much for listening and being there. I'm Aditi. Thank you.